Good evening, all. I'm here again, your chemistry tutor, Mr. Godwin. I hope your day went well. Today we'll be treating what I call electrolysis and we'll be treating some past questions. I hope you follow me this time around. Now, the last time we met, we talked of mixtures, and we talked of separation techniques and the way we separate different types of mixtures. And we also went further in talking of chemical equations, how to balance chemical equations, went down to empirical formulas and the rest. Now, the first question here is saying which of the following is an example of a mixture. Now I want you check back to what we did last time. I gave you some examples of mixture. Now they say a common salt, blood, sand, washing soda. Now if you remember, I said blood. Why? Because it contains hemoglobin and other constituents. So answer here is what? It's blood. The blood is an example of mixture. Now, a chemical compound. The second one is a chemical compound contains 40% carbon, 6.7% hydrogen, 3.3% oxygen. Now, this is the answer here. This is blood. Now, a compound contains 40% carbon, 6.7% hydrogen, 53.3% oxygen. If the molecular mass of the compound is 180, its molecular formula is what? Now, when I was doing empirical formula, I gave you the guidelines and the steps in calculating empirical formula. And I said once you've been given something in percent, you just assume them to be in grams. So now your carbon is what? Is in 53. So instead of 53%, you put it in 53 grams. Now your hydrogen, instead of 6.7%, 6.7 grams. And then your oxygen, so this is 40 grams. And then your oxygen is one that is 53.3 grams. Now, and I told you the next step is to divide each of these grams by their molar mass. Now, the molar mass of carbon here is 12. The molar mass of hydrogen is 1. And the molar mass of oxygen is 16. Now, we divide them by their molar mass. This is over 1. This is over 16. Now, the next thing you have to do now is after dividing them, I said you are to divide each term by the lowest amount. So now you divide 40 by 12, you'll be getting 3.33. So this is 3.33 by 16. Here it will be giving you also 3.33. Now I said divide it by the lowest term. Now 3.3 is 3.3. Now this is just 1. So then you're dividing 6.7 by 3.3. Now this is 2 and this is still 1. So now the question here is if the molecular mass of the compound is 180, its molecular formula is what? So now you have your carbon, which is now 1, your hydrogen is 2, your oxygen is 1. So this is your empirical formula, not yet your molecular formula. Now many people will rush to go and choose this because you are gotten this. This is just what the empirical formula. This is your empirical formula. Now, the next thing now to do once you're gotten your empirical formula is get your molecular formula. How? You're going to be equating this. This is going to be CH2 or into brackets your N equal to your relative molecular mass, which they gave you to be 180. Now next, you're going to be finding the molar mass of this compound here. Now it's going to be, remember your carbon is 12, so it's going to be 12 plus the hydrogen, which is 1, so it will be 1 times 2 because of this 2, then plus 16. And your N is still outside, equal to 180. Now this is going to be 12 plus 2 plus 16, which is 18. So this is 12 plus 18. Remember this N here is multiplying everything. Now 12 plus 18 here, giving you 30 multiplied by your N here is equal to 180. Now divide both sides by N, you have to get it. So here, divide both sides by 30 rather. This is 30n divided by 30 because you want to get your n. So now, dividing 180 by 30, now discover you'll be getting 6. So your n is doing here is what? CH2O multiplied by your n, which is now 6. Then this is O6. Now look at it. C6H12O6. So this is your answer. Remember I said once you are done, you find your empirical formula. After finding your empirical formula, you now begin to find your molecular formula. Formula. Now you equate it to the molecular mass of a compound given, which is 180. Now you find the molar mass inside. C is 12 plus 2 times 1 plus 16. Now everything here gives you 30 equals to 80 multiplied by your n. So now you are trying to get your n, you divide what's that by 30, and then your n is 6. Now in place of this n, you now put 6, thereby multiplying everything by 6. So it becomes 6 times C, 6 times Q, which is 12, 6 times the oxygen, which is 6. And that's how we got this side to the C6H12O6. C6H12O6. So it's very, very easy and very, very okay for us to understand how important. Okay, let's move to the next slide. Let's see the next question there. Okay, they said an organic compound has an empirical formula this and a vapor density of 45. What is the molecular formula? Okay, this one is quite tricky a bit because this time around they give you a vapor density of 45. Okay, let's see how we're going to do about it. They have already given you an empirical formula, so this one is there's no need of going towards that long process anymore. They'll be giving an empirical formula to be this CH2O. Then they give you a vapor density of 45. What is the molecular formula? Now, remember when you're dealing with trying to do your molecular formula, so you multiply this by n equal to your relative mass. Excuse me, but this time around you're being given vapor density. Now your vapor density or your relative mass is twice your vapor density. So therefore, in order to get your relative mass here to become 2 times 45, which give you 90. Very, very easy. So therefore, relative mass here is now 90. So what you now do is CH2 will multiply by your n is equal to 90. Now I said you find the molar mass inside. So this will be 12 plus 2, 1 2, then plus 16, which is n equals to 90. So this is this, you add them up, it's giving you 30. Now look at it very carefully. The other method was that we had to go and find the empirical formula. This time around we're not finding the empirical formula because it's really given. The only thing here is that they gave us the vapor density. So being given that we are being given the vapor density, we have to find the relative mass. So you find the relative mass, multiply the vapor density by 2. Now once you have done that, you equate it. Equating your formula, empirical formula, multiply by n equal to your relative mass. Once you have done that, you add them up, you multiply by your n, and then you try to find your n by dividing both sides by the coefficient of this n. So in dividing this, you now be getting that your n is equal to 3. Now remember that once you have gotten your n, you try to multiply it here because you're multiplying the n by everything here. So it's going to be now CH2O. Instead of your n, now you're putting 3. Now your 3 is going to multiply everything in the bracket. So it's now going to be C3H6O3. Okay? C3H6O3. I think there's an error actually here. This actually going to be answer. Here is supposed to be 3. An error actually here. So here is supposed to be 3. It's supposed to be C3H6O3. Okay. Now the next question here says how many atoms are present in 6.0 gram of magnesium? Now, how many atoms are present in 6.0 grams of magnesium? Given that your magnesium equals to 24, which is the molar mass of magnesium, and your the number of Avogadro's number here is 6.0 to 19 power 23. Now, if you are following Avogadro's, it tells you about mole, atoms, and molecules. Now, since you have been given magnesium to 24, you have to find the atoms present in it in 6 grams. Now, 1 gram of magnesium is going to be this, which is 6.0 to 6.0 gram of magnesium should give you X. Now, this is very easy to solve. There's no need of going to write length since this is an objective question. So you are going to be doing what they call cross multiplication here. So it's going to be your 6 times 6.02 times 10 to the power of 23 equal to your X times this times 1, which is Tx. So you're finding your X, which is the number of atoms. So X atom is equal to, you're going to multiply this 6 times 6.02 times 10 raised to the power of 23. So what you will now be getting here as 6.02 times 10 raised to the power of 23 times 6. Okay, you'll be getting 3.61 times 10 to the power. Okay, then 3.61 times 10 to the power of 24. Okay, actually here, what you get here first is your mole. What you get first here is your mole. Because this is a mole, let's convert it to mole. What you get first here is your mole. Okay, the next thing you have to do, because you're being given the molar mass here. So being given that you're being given the molar mass here, you are just here to find the atom directly. So once you're being given this, in order to get your atom, you have to divide the number of particles over the molar mass. So here is going to be equal to number of particles over the molar mass. So your number of particles is what you got here, which is 3.61 times 10 to the power of 24. And your molar mass here, is what? 24. That's the molar mass of magnesium, which is here. So remember I said after doing this, 1 gram is equal to 6.6 mole, and this is equal to X. So once you cross multiply, you get the number of particles that is present in magnesium. After getting the number of particles present in magnesium, the next thing to do is to get the atoms, which you now the number of particles over the molar mass. So the number of particles, which is now 3.61 times 10 to the power of 24 that you have gotten here, divided by the molar mass of magnesium, which is this 24. So in dividing it, you'll be getting 1.51 times 10 raised to the power of 23, which is this 1.51 times 10 raised to the power of 23. So that's how you actually get it. Okay, before we move to the next slide, I would like to treat on electrolysis before we just move to that one, and then we'll begin to answer some of those questions there. Okay, so now I know many of us have heard of electrolysis, or have been asking ourselves what electrolysis are. Now, electrolysis is just simple a chemical change or a chemical decomposition that occur in a molten compound, or is a chemical, or you can put it as a chemical change that is all about a current passing through an electrolyte. Now, once you are dealing with holes in the process, now there is a man named Faraday that actually proposed laws of electrolysis, proposed both the first law and the second law. Now, first law of electrolysis tells you that the mass of the element that is charged during electrolysis is directly proportional to the quantity of electricity passing through. Now, and this is how it is represented mathematically, that your mass, which is this is the mass, is directly proportional to the quantity of electricity. So this is quantity of electricity. Then you bring us the quantity of electricity. Now, although we are going to be looking at some questions, now the quantity of electricity is equal to your current, which is I, your current multiplied by the time, which is T. So this implies that your M is directly proportional to IT. Now, in order for you to equate it, to now be M is equal to EIT, where your E is a constant. Your E is a constant variable. So let's put Z, which is also a constant variable. Depending, all of them are still constant variable. Now, remember I said that the first law of electrolysis states that the mass of an element that is discharged during electrolysis is directly proportional to the quantity of electricity passing through it. Now, we're going to be safe, so okay. There's a question here that actually relates to that first law. It says, what quantity of electricity is consumed when 10 ampere was consumed in 1 hour. Consumed in 1 hour during electrolysis. Now, this question is very, very easy. They say one quantity of electricity is consumed when 10 amp was consumed in 1 hour during electrolysis. Now remember I told you that quantity of electricity equals to your current times your time. Right? Now, current is measured or it has a unit of A, which is ampere, and time is either in hours, seconds, or in minutes. Now, in order to find the quantity of electricity, remember the quantity of electricity is equal to your current times your time. And your current is being given in 10 amp. So your current is 10 amp. Your time is 1 hour, and I say you have to convert it to second by multiplying by 60 by 60. Okay, so once you do this is 60 times 60, this should be giving you 3600. Okay, so seconds will give you 3600 seconds. So now the next thing, your quantity is equal to 10 times 3600. So your quantity of electricity is equal to 36,000. Now, quantity of electricity is measured in columns. So your answer will now be what? In columns. And which is C. So this is 36,000 column. Now let's look at another question. Now, before I ask another one, let me note this down that note 1 Friday is equal to 96,500 column. You have to note this. The 1 Friday is equal to 96,500 column. Alright, so let's go to the next question. They say calculate the mass of aluminium, the mass of aluminium deposited a current of 3 amp. A current of 3 Okay, for 2 hours. For 2 hours, the aluminium, and then they give you that. I said 1 Faraday is equal to 96500. 96500. Okay, quantity of electricity. Now this time around, they say we should calculate the mass of the aluminium deposited. Now you're being given current. Now this kind of situation, write out your parameters. Now you're being given the current. Your current which is I as 3 amp. They give you your time to be 2 hours. They ask you to find your mass, right? And then we all know that your Q is equal to your IT, right? So now, remember they give you the one F is equal to 96500 column. Now the first thing here is to find your Q, because remember that your M is inversely proportional to your Q. So now, if I find your Q, so now be 3 times 60, 3 times 2 rather, because it's 2 hours. Remember that you have to convert this 2 hours to seconds, so do 2 times 60 times 60. So in converting this is 3600 times 2. Now once you are doing that, now we're multiplying 2 times 60 times 7200. So now multiplying this by 3, we're getting 21600 column. Remember I said it's a column. Now, how do we get our mass? That's the question here. It's very easy. Very easy. Now, since 1 farad, meaning that 1 farad, which is 96500 coulomb, is to 1 mass of an element discharging electrolysis. So therefore, 21600 coulomb is to X mass. So what you'll be doing here now is to be crossing multiplying. So this will now be, so now the mass of the aluminium deposited, mass of aluminium deposited is equal to 21600 divided by 96500. Now why? Because you multiply this by 1, which will still give you this. Multiplying this by x, you are dividing both sides by x, so you have to divide this by this. So this is 21600 over 96500. So now once you are dividing this, divided by 921,600 divided by 96,500. Now your mass here now will be equal to 0.2 grams. Very easy. Very easy. Now let's go back to how it was being solved. I said you calculate the mass of the aluminium. They say calculate the mass of aluminium deposited when a current of 3 amp. I say write down your parameter 3 amp is passed through an aluminium electrolyte for 2 hours. Your time 2 hours, you convert it to seconds. Now you're converting it to seconds, you multiply it by 60 by 60, which will give you 7200. Now your mass is not given. Remember that your Q is equal to your IT, which is quantity of energy equals to current times time. Now you multiply the current, which is 3, times the time in seconds, which is 7200. It will give you 21,600 coulomb. Remember I said this is C coulomb. Now from the equation we're being given that 1 farad equals to 96,500 coulomb, which is this. And I said, remember from the equation that your mass of the element discharging electrolysis is directly proportional to the quantity of electricity. So this implies that 1 farad, which is 96,500 coulomb, is to 1 mass of the element discharged. Therefore, to find the mass of aluminium which is deposited, aluminium is an element discharged here. So it will now be 21,600 of that of this aluminium now to X mass, because we're looking for the mass of this quantity of aluminium that we have just found. So in order to find it, your mass of aluminium deposited will now be the quantity of the aluminium deposited divided by the quantity of a given element, which is 96,500. So in dividing this, you'll be getting your mass as 0.2 grams. Getting it as 0.2 grams. Okay, let's see another question here. Then we'll go further and then we'll see other things here. Okay, another metal. When you put metal surface with another metal, how we call electroplating, is method of coating the surface of a metal. That's electroplating. As process of coating the surface of a metal. Okay, and also you'll be explaining how electrolysis actually works. Now once you are doing electrolysis, you take a look at a diagram, something like this. Now having its electrolyte. Remember I said electrolyte is the compound that conducts electricity and is decomposed in the process. So now these are electrolytes. These are electrolytes. Now you have an electrode deep in the electrolyte. Okay, having an electrode deep in the electrolyte, and you're having your source of electricity here. Okay, having a source of electricity here, source of current, any of them can go. So you're having your source of electricity here. This is negative. Having your cathode and your anode here. So once you're doing electrolysis, it tells you how electrons move from the anode to the cathode, from the cathode to the anode. So there is a movement of electrons there, where this will be attracting electrons from here, this will be attracting electrons from here. That is just the basic thing about electrolysis. Okay then, let's list out the uses of electrolysis. The uses of electrolysis. Okay, uses of electrolysis. Now the first use here is extraction of metal. Extraction of metals, or extraction of elements, because there are some few non-metals. So let's say metals, e.g. you have your potassium, you have your sodium, etc. Then you talk of all of those non-metals. Talk of all the non-metals. You have non-metals like fluorine, like your chlorine, and the rest. Now another use is that it's used to purify metals. Purification of metal. Purification of metal. The example here is copper. copper, you have mercury. Copper, mercury. And third one is electroplating of one metal. Remember, I told you what electroplating is. When you use a surface of a metal to coat another metal, that is electroplating. So electrolysis helps in electroplating. In electroplating of one metal by another. One metal by another. Operation of setting important components. Okay, these are the uses of electrolysis, the main uses of electrolysis. Used to extract elements. When you talk of element, talk of metals and non-metal. When you talk of metal, talk of sodium, potassium, and the rest. Then non-metal, talk of their ores. In extracting the ores of this non-metal. An example here is fluorine, chlorine. The next one is purification of metals, such as copper, mercury. It's also used in electroplating of one metal by another, and I explain what electroplating is as the process of coating a surface of or a metal by the surface of another metal. Then it's used in preparation of certain important compounds such as sodium hydroxide. Very sodium hydroxide this electrolysis. Okay, let's to the second law. Remember I said Faraday introduced not just one law, but he also introduced two laws of electrolysis. And I said the first one has to do with the mass of electricity or the mass of the element discharging electrolysis directly proportional to the quantity of electricity passing through. And the second law states that when the same quantity of electricity is passed through different electrolytes, the relative number of moles of the elements discharged are inversely proportional to the charges of the ions. Now they are proportional to the charges of the ions, and that's the second law. Second law of electrolysis. Faraday's second law of electrolysis, where you have to explain that if you have an element which has, depending on the equation you are being given, yeah, the same thing. Two of them are the same. And we'll be looking at some questions and then we'll be solving them. Then we'll see how to solve them. Remember, it states that when the same quantity of electricity is passed through different electrolytes, meaning there are two different electrolytes here, and the same quantity of electricity is being passed. The one is passing through here because there's an electrode, there's another electrode. So it's passing the same quantity is passing through here. So it states that once the same quantity of electricity is passing through different electrodes, then they are inversely proportional to the charges of the ions. Okay, let's take a look at an example so that we're able to understand what the second law is actually talking about. It said calculate. Okay, say calculate the mass of silver deposited where a current of 2.6 is passed through a solution. Is passed through a solution partial solution of a silver salt of a silver salt silver salt for 70 minutes. For 70 minutes. Okay. Now you're being given silver to be 108. Let's see. Let's say calculate the mass of silver deposited when a current of 2.6 amp is passed through a solution of silver salt for 70 minutes. Okay. Let's see how we go about this. Now, this one is quite different from the first law. Now, in solving this one, remember that second law has to do with equation. Now, your silver, which is Ag plus electron. The reason why, because silver just have 1 plus, not 2 plus. So assuming it's 2 plus, okay, then now we have 2 electrons here. So electron give you silver. Pairs. Okay, that's just one. Okay. Now, I said 2.6 amp. So this implies that we have to find the quantity first. Remember, your quantity is equals to IT. So now when you are converting this 70 times 60, this is now be giving you 4200 seconds. So this is times 4200. So this is now going to be times 2.6 times 4200 now be giving you 10,920 column. Okay. Now let's say calculate the mass. It's just like the first one we did. Deposited when the current of this is passed through a solution of the silver salt. Okay, it's actually the same thing. Same thing we normally solve earlier. Now remember 1 Faraday, which is 96500 is to 108 grams. Remember the grams of silver in this context. Okay. Now the second the mass of silver deposited when the current of this is passed through this. Okay. So now you have been given, you've solved for the quantity of electricity of this silver, which is 10,920 column. And we are looking for the grams here. So it's very easy. You have to find your grams. 8 gram is 10,920 times 108 all over 9,500. So this will be giving you, this is going to be 10,6,920 multiplied by 108. So this will be giving you 1179,360 all over 96,500 over 96,500. Now divide this by 96,500. This is 1179,360 divided by 96,500. So this will give you 12.2 grams. 12.2 grams. So this implies that 12.2 grams of silver is deposited at the current of 2.6 amp for 70 minutes. So 12.2 grams of silver at the current of 2.6 amp was being passed through a solution for 70 minutes. So that's how you get that. Okay, let's see another example here. This is another example here. Okay. This is another example here. They said calculate the volume of oxygen volume oxygen involved at 285 Kelvin temperature and 0.91 and there is 4.5 Newton per meter square when a current of 2.5 when a current of 2.5 is passed through acidified water is passed through acidified water. Okay, for 15 minutes we pass through acidified water. Okay, 1.5 minutes. 1.5 minutes. Now they give you the molar volume of the gas to be this. Molar volume, which is 22.4 GMQ. Standard pressure equal to 1.01 and 10 to the power of 5 Newton per meter square. And then 1.5 equal to 96500. Okay. Let me ask calculate the volume of oxygen evolved at 285 and 0.91 Newton per meter square when the current of this is passed through acidified water for 1.5 minutes. Okay. Calculate the volume of oxygen evolved at 285 Kelvin and 0.91 times 10 to the power of 5 Newton per meter square when the current of 2.5 amp. Remember, is passed through acidified water for 1.5 minutes. Now, the first thing here, remember your quantity, write out your parameters first. The current is 2.5, time is 1.5, which you convert to pressure 1.01 times 10 to the power of 5, being given your farad, which is 96500. Okay, now this is 1.5 times this is Newton meter per second. Okay, so now next thing is to find the quantity of electricity, which is this. So it's now your current, which is 2.5 times your time, which is 90. So this is now 90 times 2.5, which give you 25 column. This will now give you 25 columns, so you need to find the mass now. Now in finding your mass, this time around, you will not just be finding the mass, but what we are being asked is to find the volume. We're being asked to find the volume. So here we are going to be doing this. We are going to be putting this to your given volume, which is 22.4 GMQ, which is the molar volume. And then this which we have found, this is 225 is to x. Remember. And then okay. Then remember we are dealing. Calculate the volume of oxygen evolved at this and this when the current of this is passed through acidified water. Acidified water. Okay, there's actually this x. Now remember, once you are dealing with the second law, you have to deal with the equations that you need. The equation given here is your OH is to your water plus your oxygen. Okay, water plus oxygen. Okay, so this is it. Since you are dealing with acidified water, so 4 is this. For this one, we are dealing with 4 Fahrenheit. So if 1 Fahrenheit is this, so it will be 4 Fahrenheit, it will be 4 times 96500. Now this will be this times this and this times this. So what you're getting is 225 times 22.500. Alright, let's question here. So now we're going to be multiplying them times 22.4. So here we'll be getting 5040 and 40. Then like both of them, this will be 5040 divided by 386,000. So this will be giving you 0.01. Okay, let's give it that 0.013. Okay, 0.01306 GM cube. Now we are converting this from GM cube to CM cube. We are converting this from GM cube to CM cube. You have to now be multiplying it by 1000. So once you multiply it by 1000 to convert it to CM cube, you'll be getting 13.06 CM cube. Okay? Now, these are STP. Now, the next thing we have to find here is the thing involved. Now, look, I said once we are done with this, we'll just go straight and then we'll find the quantity of electricity, Q equals to IT, and then we got 225, and then 1 Farad is equal to 96500 C, which is this. And I said from the equation here, you are dealing with 4 electrons, which is 4 Farad, so 4 times this. And that's how we got the 386,000. You divide it, you get the total volume of the equation here. Now the main question here is that you have to find the volume of the oxygen. Now you have to find the volume of the oxygen. Okay? Find the volume of the oxygen. Remember that I've already gotten V1 now to 13.06 cm3. Okay? So now to find the volume of the oxygen, we're using general law. So using general law, to be P1 E1 over T1 equal to K to all over 2. Reason why? Because we've been given all the parameters. Remember, you've been given your temperature to be 285 Kelvin. Now, this is your second temperature, second pressure. Remember, they say at STP. The second pressure here is, okay, your first pressure here is this, which is 0.91 and it's 10 to the power of 5 Newton per meter square. The second pressure is being given as, I think that is 1.01. Okay, that's 0.91. Being given as 0.91. Okay, then the second one is being given as 1.01. This is 1 point. Okay, so that's 1.01. So being given as 1.01 and 10 to the power of 5 Newton per meter square. Okay, then your temperature, the first temperature, which is your standard temperature, is being given as 273 Kelvin. Now, your volume being given as 13.06 cm3. So what we are asked to find is the second volume, which is the volume of the oxygen involved. Now, if you are dealing with P1 over T1 equals to P2 V2 over T2. So now your P1, which is this is 0.91 multiplied by 10.06 all over your T1, the T1 which is 273 equal to your T2 which is 285. Okay, so since we are finding this cross multiply, so you'll be having 1.01 times 10 to the power of 5 is 273 times P2, equating it equals to 285 times 0.91 times 10 to the power of 5 times 13.06. Okay, so your P2 is equal to 285. Trying to get V2 from here, so we have to write it by all of this. Divided by 1.01 times 10 to the power of 5 times 272. Okay, so this is now 285 times 0.9, okay, 0.91 times 10 over 5, okay, times 285, okay, times 13.06. Okay, just 338,711,100, dividing by the next one, which is 1.01 times 10 raised to the power of 5 times 273. 27573,000. Now you divide this stuff. So this divided by 27573. Okay, 27573,123. Okay, so your second volume here is now going to be 12.28 cm. And that's how you calculate the volume of the oxygen involved at 285 Kelvin and the 0.91 times 10 power 5 meters per meter square. Now remember the process I told you. We have to calculate the volume of the oxygen. The first is to calculate the first volume of, because you're not giving the volume, you're giving the molar volume of this equation. So you have to calculate the first volume. How do you do that? It was this OH, and then you have water. Remember they said amplify water, and then plus your oxygen, then plus 4 electrons are being moved, and then we found the quantity of electricity. From here, we now found the volume here. So next, after finding the volume, you use your general law, P1 V1 over T1 equals to P2 V2 over T2. You are finding V2, make V2 the sorry formula, and then you'll be able to solve it. Using V2 as your formula, you can get P1 V1 T2 all over P2 T1, which is what we did here. This is what we did here. And then once you get it, you get your final volume, which is the volume of the oxygen involved, which is 12.28 cm3. Okay, we'll be looking at some questions on this slide now. We'll be able to see if there are questions, and then we'll be able to run on some questions. Okay. All right. Now let's say calculate the volume of 0.5 mole per gm cube of H2SO4 that is neutralized by 25 cm cube of 0.1 of sodium hydroxide. So we are dealing with an acid and a base. I'm dealing with temperature of surface 6 and I'm dealing with sodium hydroxide. And this is you calculate the volume. Since you have been given this mole per dm cube, so this is the molar concentration of this. This is the volume of this one. So this is actually very easy. Now when we are dealing with this is H2SO4 plus sodium hydroxide. Remember I taught you balancing equation. So you know how to balance equation. Remember I said you pick. So you'll be getting NaSO4. Okay. Okay, then you now need to balance. You look at where it's not complete and then you need complete. So now this is 2, this will be Na2SO4. Okay, so the oxygen here is now 6. The oxygen here is still, the hydrogen is 2, 2, 4. So the hydrogen has to be complete 4. So the oxygen is 6, 6. Sodium is 2, 2, and everything is complete. Okay, so the mole ratio here is 1:2. Mole ratio is 1:2. This is 1:2. Now when you're giving a really volume of your acid, which is this, so that's why this is going to be CaVa over CbVb, which is equal to your mole ratio. Mole ratio, which is 1/2, which is 1/2. So now the concentration of your A, concentration of your base is 0.1 mole per dm cube. Volume of your acid, which we don't know, volume of the base is 25 cm cube. Okay, so we can just use this and solve it. Now you see A, which is 0.5 multiplied by your VA, which you don't do, over your CB, which is 0.1 multiplied by 25 equals to 1/2. Now you do your cross multiplication here, then you now be getting 2 times 0.5 times this, got 0.1 times change, so this is going to be over 2 times 0.5. Okay, so this is going to be 0.1 times 25. So this is 2.5. It's going to be giving you 2 times 0.5 over 1. So this implies that this is going to be 2.5 divided by 1, which is 2.5. Okay, you see how we solved it. Said calculate the volume of 0.5 mole per dm cube of temperature of 6 that is neutralized by 25 cm cube because of the mole ratio. Using this equation to recover that you just have one atom here, 2 atoms here, so that's 1:2. So when you're able to do that, we have to calculate your volume of gas, which is 2.5 cm cube, and that is 2.5 cm cube. So that's how we're able to get this answer, 2.5 cm cube. Very, very easy. Very easy. Okay, and the next question says find the volume of the gas at STP, which is standard temperature and pressure. If the saturated vapor pressure of water at 10 degrees is 5 millimeter, inversely proportional to the pressure, we'll be talking of your volume is inversely proportional to your pressure, where once there's a constant, we get Q over P. So this implies that your K is equal to Vp. This is Boyle's law. This is Boyle's law. And I want to talk of Charles' law now. So your temperature, meaning that is KT. Your pressure is constant. This is Charles' law. And this one is Boyle's law, where your temperature is constant. Okay, so once you notice the question that your temperature is constant, the same temperature, 10 degree, 10 degree, it tells you that this is Boyle's law. If the pressure is the same, it tells you that that's Charles' law. Okay, so this is now Boyle's law. Being given that 50 cm cube of gas was collected, so your V1 is equal to 50 cm cube of collected over water, and then your pressure P1 75 millimeter mercury. Then calculate the volume of the gas at STP, which is standard temperature and pressure. Standard temperature and pressure. If they saturated the vapor pressure of water at this disease, so your P2, your second pressure is what? 5 millimeter mercury. So you can see that it's very, very easy to solve now. So you are going to be dealing with your V1 P1, or you can make it P1 V1 equal to P2 V2. Now we are finding our V2 because we don't know our V2 in the question. So now P1 V1 equals to P2 V2. So in order to find your V2, you have to by P2 by P2. So this implies that your V2, is equal to P1 V1 P2 all over P2. Your P1 V1 over P2. So that's your volume. P1 V1 over P2. So now remember your P1 is 75, it should be V2 is equal to 753 multiplied by your V1. Your V1 is what? 50 all over your second pressure, which is now 5. So your V2 is equal to 753, so 753 multiplied by 50. So this will be giving you 37,650. 37,650 all over 5. So you divide this off, this is going to be divided by 5. So your second volume. Okay, let's go back to how we solved it again. I said once you get this thing, get this is 7.5 to your first pressure. Now to get it, P1 V1 equals to P2 V2. To get your V2 into P1 V1 divided by your P2. Now your P1 was 753 from the equation to 753 millimeter mercury. Your P2 was now your V1 rather was now 50 cm cube, and then your V2 is what we are looking for. So it's now the P1, which is 753 multiplied by 50, which we did 753 multiplied by 50. We get to 7,650. Now your second this thing was 5. So you now do it divided by 5. Okay. Okay. So these are trying an error for the question here. Okay. Anyway, once you have been given this kind of question, 50 cm cube of gas was collected over water at 10 degrees Celsius, 75 millimeter mercury. Calculate the volume of the gas at STP. If the saturated vapor pressure is at this, so I'm guessing that mistake here is from this, although it's the graphical mistake. So now this is the right way to do it. We're given this 753 times 50, which is your first pressure multiplied by your second, your first volume, you now divided by P2. Okay. So we are able to do that as 50 divided by. If you're able to do that, you should be getting something like this. 765. You should be getting 7,530. I guess there's a look at the next slide. It said during titration experiment, 0.05 mole of carbon 4 oxide is liberated. What is the volume of the gas liberated? Now we are dealing with carbon 4. And dealing with carbon 4 oxide. Carbon 4 oxide being liberated and then they ask you what's the volume of the gas liberated. Now remember that your carbon here is 12. Now in this case, you don't give all this thing, so you ought to know it. So oxygen is 16. So the molar mass of this is going to be 12 plus 16 times 2. And this is equal to 12 plus 32. So 12 plus 32 here, this is 4. This is 44 grams per mole. Okay? So now 0.05 moles of this is liberated. Now they ask you what is the volume, of this. Now 22.4 dmq, which is the molar volume of the gas, standard volume of every gas is 22.4 dmq. So the 2.4 dmq is to 1 gram. Okay, is to 1 gram, or you could say it's to 1 mole. Now this time around, we are looking for x dmq is to 44 mole. Okay, since we made is to 0.05 rather, it's to 0.05 this time around. It's to 0.05 because we've been given 0.05 mole of 4 oxide. So now in order to get it, remember you have to do what they call cross multiplication. So it's going to be 22.4 times 0.05 all over 1. Okay, which is this? So that's 1.12 dmq. Alright. The next question says oxidation number of boron in this is what? Now, remember the last time I told you how to calculate the oxidation number. So once you get this sodium here is 1. Since we are finding for boron, so it will be plus x. Remember your hydrogen here is now standing as an angle, so it's now going to be plus into bracket 4 times minus 1. Instead of the normal plus 1, it's going to be minus 1. This is equal to 0. So it's going to be 1 plus x. So this is 4 times minus 1, which is minus 4. So it's going to be minus 4 equal to 0. So this is now going to be x. 1 minus 4 gives me minus 3 equals 0. So your x is equal to plus 3. So here your answer is what? Plus 3. Okay, the next one is the permanent hardness of water can be removed by filtration below. Cannot remove permanent hardness of water by filtration. Okay, addition of slakline. And once you are talking of slakline, you talk of calcium oxide, which is also quicklime. Then there's addition of caustic soda. There's boiling. Boiling is for temporal hardness of water. So it shouldn't confuse you. Temporal hardness of water. Hardness of water. That is where boiling comes into play. And if you use it for permanent, that's where you now cause pouring of in kettle. So your answer here is more of slakline. You use slakline, and then you'll be able to move permanent hardness of water. Okay, let's go to the next slide. Go to the next slide and then see. Okay, calculate the percentage by mass of nitrogen in calcium nitrate 5. Calcium nitrate 5. Now we're calculating percentage in any compound. Now this is calcium nitrate 5. Nitrogen is calcium nitrate 5 with calcium trioxonitrate 5. Okay, calcium nitrate 5. Now, the first thing you have to do here is to find the molar mass of the compound. To find the molar mass of this compound. Now, you find the molar mass. Remember, you are giving your calcium to be 40. So this will be 40 plus. Remember that this 2 was 9 everything. So this is 14 plus the oxygen, which is 16 times 3. So this is 40 plus. This is 14. This time this is what? That's 48. Okay, so that's 48. That's 14. We should use 48 please times 2. So this is 6. This will be giving you 164 gram per mole of this compound. Now we are done getting the gram per mole of it. Okay, now we have this as total. We see to calculate nitrogen from inside, the percentage of nitrogen. You have to calculate the nitrogen. You have to do this is going to be the mass percentage of nitrogen equal to nitrogen over molar mass of the compound. Now we have 164 as a molar mass. We have 164. So the amount of nitrogen here is 14. So the percentage, remember times 100. When you are doing the percentage, everything times 100. So the percentage of nitrogen is going to be the mass of nitrogen, which is 14 over 164 times 100. Okay. So this is 14 over 164. 14 over 164 times 100. So once you do this, you're getting 8.5% of nitrate here. First thing, you'll be able to write out your compound. What compound are you dealing with? And when you're dealing with this kind of compound, now to me, once you're dealing with this is the bracket, and then there's an exchange of valence here. So this is final. So that's how you do is to find the percentage of that element you are looking for. So percentage of any element is equal to the mass or the molar mass of that element over the molar mass of the given compound times 100, which we have done here, give us 8.5%. Okay, they say calculate the solubility of water at 120 degrees C. You've been given that your copper is 64, your sulfur is 32, and your oxygen is 16. Okay, this is very, very easy. We're given some terminologies that you will use once you are calculating anything. Now, once you now come something as solubility, you can use your mass in grams or molar or mass. You can use your mass in grams. Okay. Molar mass, and then you can use to solve it. But the one we've been giving here already is we've been giving you it's very, very easy for us to solve it. Bring your mass in grams of this dissolved in 100 this at 120 degrees C. Now, in this 120, everybody now be rushing to it. We're giving 100 grams here. We're giving 40 grams of this dissolved in this. So if 40 grams have been dissolved in 100 grams, 40 grams of this is dissolved in 100 grams of water, post. That's we have just 1,000 grams of water as constant. When converting mass in gram. It just needs to be 40 times 1,000 by 100. So this is just normal arithmetic. It's just KGF for molar mass. Why? Because the molar mass of this, the unit here is what? Is gram per mole. Is gram per cube. Okay. Now we need to find the molar mass of CuSO4. The molar mass of CuSO4. Remember, we're given 64, so it's 64 plus sulfur, which is 32 plus 16. So this is 64 plus 32. Okay, remember it's 16 times 4. So your 16 times 4, I think should give you 64. So that is 64 plus 32 plus 64 again. So your molar mass here is 160. Okay, now what we got here is gram per GMQ. Now we are getting our molar mass to be 160 gram per mole. Coming back to the formula, I see mass in gram per GMQ or molar mass. This grams cancel, so you're left with per GMQ. So you come here, solubility, this CuSO4 is going to be equal to this, which is 400 over the molar mass, which is 160. And once you're ready with this, as 400 divided by 160, okay, this should be giving us 2.5 mole per gm. 0.5 mole per gm. 2.5 mole per gm. Remember the way we solved it and how we explained it. Say calculate solubility in mole per gm cube. Now most of these things we do here is we use this unit to find what you're looking for. Remember, I'm going to be writing down some terminologies on how to find some stuff. So you're being given 40 grams. Remember, I said 1,000 grams of water is considered as a constant. Don't convert it from mass to gram, in grams to mass, in gram per gm cube. It should be on your mind. They must not give you that it's 1,000. Always, once you're converting from grams to mass in grams, you're multiplying by 1,000 and then divided by the gram of water. So therefore, we did that and we got 400 grams per gm cube. After getting that, the next step is to find the molar mass of this compound here. The molar mass of this compound. Remember, you're being given this question that the copper is 64 and the sulfur is 32, the oxygen is 16. It's very, very easy. So what you do here is 64, which is your copper, plus 32, which is your sulfur. Remember, your 16 here is this is O4, so you multiply 16 times 4, which is 64. So now be 64 plus 32, 32 plus 16 times 4. So that is 64 plus 32 plus 64, because this gives you 64. So everything is giving you 160 grams per mole. Once you get 160 grams per mole, then you now begin. So solubility of this is equal to mass now, which is now your 400 over 160, which is 160. Very precisely getting 2.5 mole per gm. Okay. Let me just write out some stuff before we go to the last slide. Okay. Now, when you're calculating your mole, you're calculating for mole to be equal to your mass or molar mass, which is gram over gram per mole. Okay, we cancel this, so the unit is mole. Okay. Then the next thing you are calculating for, just like one we just did, molar pump, or you call it solubility. Molar pump or solubility. Say you're using mass in gram per gm cube, gram per gm cube, all over your molar mass, all over your molar mass. If you are asked to find your mass from here to be your mole times your molar mass. Okay, when you're talking of atom and the rest, which is the same thing as mole, or you can call it atom, depending. You can say number of particles all over molar mass. Number of particles, you can call it, don't put it as an amount. It could be amount of moles, amount of atoms. So it will be number of particles over the molar mass. Okay. So now let's see the last slide. Let's take a look at the last slide. What is the concentration of a solution containing 2 grams of sodium hydroxide in 100 of a solution? Okay, that is actually very simple, just like the first one we did. You've been given this 2 grams of this. So remember, you have to convert it from, because your concentration here is talking of solubility. So you have to convert it here from mass in grams to gram per gm cube. I have told you how to do it. All you have to do here now, since you've been given 2 grams, so you're doing maybe 2 grams like 1,000 is equal to your mass in gram per gm cube all over the molar mass. The molar mass. So now we have to find the molar mass of sodium hydroxide. Now the molar mass of sodium hydroxide here. Remember, sodium hydroxide, this sodium is 23 plus 16 plus 1. Science easy, this is 23 plus 17. And then this is 70, this is 0, 14 now the more. So very easy here. So you just come here, multi-gram per gram. So you are getting 20 as this, so it now make your concentration is 1 to 20 over 40. So this will now be 20 divided by 40. So you're getting 0.5 mol per GMP. So this is 5. So you'll be getting 0.5 mol per GMP as your answer. Now the next question now is what quantity of aluminium is deposited when a current of 10 amp is passed through a solution of aluminium salt for 1,130 seconds. Now remember how the first lesson when I was talking about electrolysis and I gave you some rules, I wrote some equations and how to solve that with this. Now you are being asked the quantity. This quantity now is not just your normal quantity of aluminium. Okay. Remember you are being given your aluminium as 57, Faraday is 96. Okay. So now you're dealing with 3F. Now what you have to do here first now, before the equation, is to find the quantity of electricity first. So now to find the quantity of electricity, remember I said your Q is equals to your IT, right? Now your I have been given as 10, your T has already been settled for you as 1930 seconds. So there's no way of you converting from unit to unit. So this will be giving you 19300 column. Now, okay, this is wheels. Okay, now since it's 3 electrons, I'm just asking you 3 Faraday. This is giving you 289,500 column. Okay, so now we have to make this. Here we say first one because it's 19300, right? So this is 19300 volume is to x gram, right? Then this you've gotten here 289,500 is to 300 times 27 over 289,500. Okay, so now this will be 19300 times 27 19300 times 27. Okay, this will give you 521,100. So this is 521,100 all divided by 289,500. And once you divide this, that's 521,100 divided by 289,500. We're getting 1.8 column. 1.8 grams, right? Of course, I'm dealing with grams here. 1.8 grams. Okay, very nice. So we are telling you the answer here, 1.8 grams. Now look up again, let's go through what we did. I said once you have been given something like this, quantity of aluminium is deposited when a current of 10 amp is passed through a solution of aluminium salt for 1,930 seconds. Now you are being given your aluminium, your mass of aluminium as 57, your farad be 96,500 column per mole. Now your first thing is to find the quantity of electricity. Okay, Now what they ask you, they didn't ask you for quantity of electricity, they ask you for quantity of aluminium deposited. You're actually looking for the mass of the aluminium. So you have to find the quantity of the electricity first, multiplying the current by the time, which is 10 times 1930, which will give you 19300. Now after getting 19300, the next thing is to write the equation. So remember that aluminium is 3 plus, so it will be plus 3 electron. If assuming it's 2 plus, it will be plus 2 electron. So so far is 3 electrons. You multiply your 3 by your Faraday, which your Faraday is what 96500. Now with 3 times 96500. So you give you 289,500 column. Now once you're being given that, now your 19300 column is to X gram because that's the gram of aluminum we're looking for. We don't know it. But remember that your 289,500 column is equal to your 27 gram of aluminium. So here you cross multiply. So it will be 27 times 19300, which is equal to 289,500 divided by x. Finding x, you have to by coefficient. It will be 19300 times 27 over 289,500. Now, once you multiply these two, you get 521,100 divided by 289,500. Once you divide these two, you'll be getting 1.8 grams. And that is how you substitute the quantity of aluminium. Okay, let's go to the last slide to get the quantity of aluminium. Okay. Alright then, let's go to the next slide. The last slide. It said what number of moles of copper 2 will be deposited by 360 columns of electricity. Okay, this one is quite faint. Somewhere you're being given asked number of moles in copper 2 is deposited by 360 columns. Okay, so there's no need of us going to find the quantity. I really need a bunch of electricity as 360 columns. So what we have to do here now is write the equation. This is Cu2 plus 2 electrons gives you Cu. So this is Us. Okay. So now is a 2F. So remember it's now with 2 times 96500. So once I actually with 2 times 96500, 96500 giving you 19300, 19300 column. Okay, that's 19300 column. What are we giving that? So remember, okay. So remember that once you're dealing with this thing, you just look at what you're being given. I said you are just to form the equation of your given Cu2 plus, so there will be 2 electrons giving you copper. Because of the electrons that you now deal with 2F, which now be 2 times 96500. I'm dealing with 2 times 96500. Okay. Let's.
Sorry, it's not all. No worry, no worry.
All right.
Come on.
Let's look at next thing to do.
Just goes up, just maybe there is something is wrong somewhere. My inverter is supposed to this is connected directly to the inverter, so it's supposed to go
Let's
up.
see. Right.
I'll wait to check.
Remember, so we're bringing in 360 columns. So all you need to do here now is to say the 360 column is the X O, which we don't know, and then this which is 19300 is what we are dealing with copper, and from the first one we did, then the copper is 64. Okay, so this is 64. So what you do here now is do your cross multiplication. You do your cross multiplication. You do your cross multiplication. It will be 360 times this. So this is now going to be your x is equal to 360. Remember, we are dealing with grams first. This is grams, so 364 divided by 19300 will give you 1.19. 1.19, let me say 4 grams. And we are not done. Remember, so once you are trying to find mole, your mole is equal to what? Your mole is equal to your mass over your molar mass. Which our molar mass is over 64. The molar mass of copper here is 64. So divide 1.194 over 64, you should be getting, okay, that's 0.018, okay, 0.0187. That is up. Not even up, we are doing it in decimal figures. This is 1, this is 2. This will be 1.87 times 10 to the power. Okay, this is 0.0187. This is 1, 2, 3. Okay, so that is maybe giving you 1.87 times 10 to the power 3 more. So that will get this as our answer. Say it's 12 minus 3 more. So once you've been given your current here, so the next thing now is just to write down the formula, and then we get 360 is to 8 gram, 19300 is to 64 gram. So S gram is to this, so 360 times 64 for 19300 get 1.194. So once you are done with, okay, for the last one now, an isotope has a relative atomic mass of 15. Okay, and now talking and dealing with isotope. Limit having the same atomic number, different mass number. So now remember the relative atomic mass or number of 15 and mass number of 31. Number of proton it contains is what? Now, when I'm dealing with proton is something as number of atomic number. Now, remember they are telling you the relative atomic mass of 15 and the mass number of 31. The number of relative atomic mass of everything here, meaning the total of everything here is what? Is okay, the relative atomic mass is something as the atomic number is now 15. Is now 15, meaning the atomic number here is 15. This is 31. Having atomic mass of 15 and mass number of 31. So there's no even need of going further. Since the mass number of 31, atomic this mass and atomic number same 15. So they are equal to 12 mass. Well, okay, let's see what we have here. Okay. Let's see what we have here. Let's see what we have here. Let's look what we have here. Okay, dealing with carbon 4. Carbon forms 2 important oxides, namely carbon 4 oxide and carbon 2 oxides. Okay, I'm going to be looking at their physical properties and the chemical properties of both carbons. So, physical properties of carbon 4. Physical properties of carbon 4. Yeah.